Okay, differentiate each of the following with respect to x and simplify your answers where possible. So that's the type of question that comes up in the exam, and you get given then a function such as follows, right? And the function's in terms of x, isn't it? Okay, so what we'll do is, when that's given to us, we'll call the function y. So we'll say y equals, all right? That's what we'll do there. So we've got like a curve then, which could be drawn from that, and we're going to differentiate it, right, with respect to x. So what we're ultimately looking for is this function, isn't it? The dy by dx. That's what differentiate means. Differentiate y with respect to x. And we get our sort of gradient function, all right? But when you see a question like this, of course, it's quite challenging to differentiate this. You've got a bracket to the power 15. What we don't want to be doing is writing this bracket out 15 times and multiplying and expanding. We'd be there for hours doing that, okay? So what I've shown you before is we can use the chain rule, okay, what we've learned in lessons before. The chain rule, okay, breaks this down and makes the calculation possible in a few easy steps. I'm going to show you sort of how it works to start with, and then of course I'll show you the sort of short form of it, the quick way of doing it. So what we do with the chain rule, of course, we introduce a different letter, okay, and the letter we introduce is u, right? So what I'm going to do is I'm going to say, look, let u equals 1 plus 2x. And all I'm doing there then is, right, with this different letter, is I've got really this u in terms of x. So, you know, like with our axes, x and y axes, where you've got x and going across and you've got your y going vertically. Now in this case, I've got my x going across, but I've got my u going vertically, okay? It's no different to y and x axes. It's just I've got a u and x axis in this case. And I can find the gradient of this, right? Find the gradient of this. So I need to do in this case du by dx, wouldn't I, to get the gradient. So du by dx. If I differentiate this, well, 1 becomes 0, 2x becomes 2, all right? So that's nice and easy. Go back to the original function, right? Now I can rewrite that as y equals, now this is u, yeah? I've called this u in the bracket to the power 15. Okay, so that's essentially what I can write it as, yeah? And, you know, when I look at it like this now, I've got y in terms of u, well, that's just, now, I've got a u axis here and a y axis there, all right? Just like I've got an x and y axis, but I can find the gradient of this curve here, okay, by doing dy by du. Okay, so dy by du is equal to, well, this is easy, okay, simple differentiation, bring the 15 down, and then take 1 away from that, so it becomes 14. So I've got that. Now the chain rule, right, the chain rule quite simply says that to get what we want, now remember, to get what we want, we've got to go back to this original here, yeah, this original function, which is y in terms of x, and you know, to get the gradient, and I need dy dx. So to get dy dx, right, chain rule says if I multiply these together, I'll get dy dx. And if you see it, right, you've got dy by du here, right? So times that then by du by dx. In fact, then the du's cancelled, don't they? That cancels with that. I'm left with dy dx. So all you've got to do is times them. So I've got 15u to the power 14. That's what dy du is, times du dx, which is 2. Okay? So I've got that there. And then finally then, just to finish off, of course, you know, I want it in terms of x, don't I? Yeah? Because that's what we want, the function in terms of x. So I've got to replace back now the u. So remember now, u is 1 plus 2x. Okay, so write it back in to the power 14 times 2. Right, now that's how the chain rule works, right? That's the long way of it, long form of it. But it is a quicker way, right? It is a quicker way. If I show you, this can be simplified down. So if I go back to the original, okay, original question. Now, the chain rule, quite simply, tells us, right, that all we've got to do is, to get dy dx, is we differentiate the outside first, right, the outside function, which is this bracket to the power 15, and then we times it by the derivative of the inside. Now let's just do that. If I differentiate the outside, okay, so it's a bracket to the power 15, let's differentiate that, so I bring the 15 down, bracket, and then of course reduce that to power 14, and then I've got to times it by the derivative of the inside, and differentiate in here, I just get 2. So just exactly the same as that there. Okay, so it's a much quicker way of doing it, all right, than going through all this process. But what you've done here really is just simplified this. Okay, it's just put it in simple terms. All you've got to do, as I said, think of this as a function of a function, right? That's what's going on. This is a function of a function. The inside function is 1 plus 2x, and then the bracket to the power 15 is acting on it. Okay, so you differentiate then the outside function, which is this bracket to the power 15. So you bring the 15 down, reduce it by 1 to get 14, and then you times it by the derivative of the inside function, which is 2. Okay, and this is exactly what's going on here. To finish off, of course, it does say simplify, so you bring that 2 to the front and times it by the 15, so you get that there. And there's our answer.